Hello everyone, I am Alex Braxator. In this video, I'm going to show you a solution in TIBCO Spotfire, which I have developed to make time series forecasts easier in Spotfire, which also works in a professional setting. So I have been a user of TIBCO Spotfire for 1 year now. I have set up my own dashboards for a business intelligence team and supply chain team while working closely with Spotfire information links, R data functions, and Iron Python scripting capabilities to produce the most relevant and useful visualizations. So there wouldn't be a need for a solution without a problem, and so here's an outline of my main issues with Spotfire forecasting. First of all, there's only one model supported, abbreviated HW, that is the Holt Winters triple exponential smoothing model. Albeit it is very, very easy to implement in Spotfire. It's as easy as right-clicking a line chart and pressing the button for forecast. My second issue is Spotfire doesn't output the exact values of the forecasts or confidence intervals. I have actually seen business intelligence professionals using rulers on their computer monitors to guess a value for next month's forecast based on that point's location on the y-axis, according to the ruler. So definite need for improvement there to actually export the values of the forecast and confidence intervals to an actual data table with numbers instead of just eyeballing. And number three, it is a little clunky to change some important output forecast parameters like the number of months ahead you want to predict, as well as the confidence interval. Um, so yeah, if we look here, for instance, we get a line chart and we can press right click forecast. There's our Holt Winters forecast, and what, like I said with issue number 2, you cannot see the numbers here at all. It only tells you details about the forecast, the fitted forecast that it chose, but you cannot get the exact values of these numbers right here. So that's the first, or I guess the second problem that I outlined. And with regards to the confidence interval and stuff, you can go here to lines and curves and forecast Holt Winters and edit that. And this is where you can change the number of time periods edited. So that's actually totally doable because you can set it from a document property. And what that means is you can put an input field up here, right? So that the user can put in whether they want to forecast 12 months ahead, 24, and you can link that right here with a document property. However, no such property exists for the confidence level. So if you are a user without any author license, there is no way you'll be able to reach this screen and change this number if you want to, say, view a 50% confidence interval for your forecast. So for this video, unless you are not a crypto follower, we will be looking at a very familiar time series, namely the price of Bitcoin compared to the American dollar. So we will have the daily highs, lows, openings, and prices of Bitcoin. Any of these four values here are valid to input into a time series as long as you append the date column. So I'll be going ahead and visualizing the daily average price of Bitcoin. So here's what that looks like in a line chart. We need to go to average price. And so the first step of our solution would be to export these numbers here for each month or day, depending on what we want to forecast, whether it's a daily or a monthly forecast, and export all these numbers into a file that our data function could read, namely a Spotfire data structure. So we will actually be using a document property in a very clever way to get this done. But first, we got to create a cross table of this exact visualization, and we can do that by duplicating the visualization and switching the visualization to cross table. And so here, in order for the script to work, actually, we need to do date, fiscal year, quarter, month, day of month, and average price. And so whether we want to look at month or days, we just got to make sure that these axes line up. And so I believe we're going to just look at the month for this example. So that's what the average price of Bitcoin was in February 2012, about $5.08. So you may be wondering, why don't we just use our original data table as the input for our data function? Well, with this specific data set, we actually could, but consider a more business-like data table where Each row represents a product transaction. You can have multiple transactions per day, a different number of transactions on different days, and just millions of transactions overall. So to forecast next month's dollars of said product, you would need to aggregate its values somehow, whether it be daily, monthly, or quarterly. So that's where a cross table comes into handy, like an Excel pivot table, in that it just aggregates the values on a certain time basis whenever you want. Furthermore, it is much better to complete this aggregation step using a Spotfire cross table. And by better, I mean more efficient, because Spotfire can perform aggregations of millions of rows of product transactions into a simple cross table in the blink of an eye, like this. This is much more efficient than computing these aggregations with IronPython, or even worse, R, which I tried to do on a couple million rows, and it took about 10 seconds for it to complete the aggregation step. And lastly, as we will see soon, the cross table has a very handy function called export text, which will actually export these values into a CSV file, tab delimited, along with the date columns, which we will have to parse ourselves into dates that R will recognize. The cross table, to my knowledge, is the only Spotfire visual object which has such a function like export text. So that is the main reason why I am using this as our input. So we're going to might as well call this input. And since it's going to be just kind of like running behind the scenes to get the values of this line chart, I'm just going to go ahead and move this to a separate page to save ourselves some real estate. So once again, so I'm actually going to take a look at average Bitcoin price. So make sure our two visuals have this as our value axis, which they should. It's both monthly. Cross table should have year, quarter, and month. The one numerical column, nor the work of my Python script for now. Updates coming soon. And so I will need to set up a button to trigger a Python script for the cross table export text. So I'm going to set up a new text area here, edit it, and insert a new action control. And we're going to need a script tied to a button. This button will go away later because I like to have things refresh automatically, but for testing purposes, we're going to click a button every time to trigger our script. Let's call it process, or maybe export cross table. And we're going to do a new script. The Python that I'm about to copy and paste is available. It's attached to the link in the description of this video, and it's called process.py. It's the only Python attached, and we're about to go over it line by line. So let's just call it process. And here we can see the necessary imports. We need a stream writer, file mode. We need to import from Spotfire the cross table object in order to use its export text function. And we're going to need data writer type identifiers, a temp file package to set up temporary files to save our cross table plot to, so that it will work regardless on what computer we're on. So instead of typing a absolute path right here that will only work on my machine, we can use the temp file class to just get a temporary directory that Spotfire knows where to look for, and then we can call the file itself anything we wish, and we can set up a stream writer with this temp object. So we can now we can use the export text function tied to this stream of our cross table. So we got the first casted as a cross table plot object, and this cross table right here is going to be our first script parameter. So we're going to go ahead and add it right here. It is a visualization, and namely it is the one on page 2 with the capital input. And so after this, we got to close our stream and open up a new one for reading this CSV file in our temporary location. And we're going to save this to a document property, namely one of a string that we're going to call CSV. So CSV is literally going to be a string with a comma delimited representation of our data, namely of our cross table plot. So here's where we actually parse through the dates, because right now they're written as Jan, Feb, Mar, and Apr, which is not desirable for R. We want to have those as numbers, and we loop through those and append our CSV, comma delimited with new lines at the end of each line. And we save that CSV to a document property called forecast input. And if this all works, you should see the CSV at the bottom of the script, but it doesn't work because we have not yet set or forecast input as a document property. So we're going to go ahead and do that real quick. Go to Edit, Document Properties, New, and for the property name, we have to call it Forecast Input Camel Case. It is a string because it's going to be a CSV representation of our cross table plot, and the value can leave it empty for now. Okay, now we can export cross table, check our document property to see if it updated, and it did. This is the CSV string of our cross table plot right here. All right, next we get to read our CSV document property into an R data function. First, we have to register such a function, and you are welcome to take a look at the code that I have attached in the link in the description. Just a disclaimer, I am working on a free trial version of Spotfire at the moment, so I only have TIBCO Enterprise Runtime for R, otherwise known as TER. In case you don't know, Spotfire has their own built-in R engine within the application called TER. It has its pros and cons, and pros are that it's computationally very fast for most R scripts, but its cons are that it is a custom version of R that only TIBCO uses, and that means sometimes you will run code that runs perfectly fine on RStudio, and it just won't work in the same environment. It won't work in a different environment, such as TER, due to different versions of libraries and overlapping function names in the namespace. So if you're able to work on open source R with your current version of Spotfire, I highly recommend and welcome you to look at my non-tear script attached to the video. It's there I use the auto ARIMA function to include a fresh, brand new forecasting tool in the Spotfire, namely the ARIMA statistical model. If you follow along with that script, you will still be able to follow along the video, but you may have to repeat a few certain steps that should be really obvious to be able to visualize your ARIMA forecast. Let me know if you need help with that. Right, so in TER, you are limited by the initial number of packages you are given to work with. In order to produce a Holt Winters model, we need to install the forecast package into TER. If you do not already have the forecast package in TER, you can go into Tools and TER Tools to copy the engine path of TER to your clipboard, which you can open up in your file system. It is located in the bin directory, and we'll open up ter.exe. And here we can type in the canonical R command to install a new package, which is install.packages, quotation mark, forecast, the name of your package. And I've already done this, but I will wait along with you as your command line runs. And now we should be able to get the TER version of our R script to run. So I'm going to go ahead and copy and paste that real quick. Where's my Sublime text? We can here. Come back to Spotfire. Now we're going to go to Edit, Data Function Properties, and we're going to register a new function. So we're going to call this Forecast. And it's going to be TIBCO Enterprise Runtime for R is my only option, but once again, you can use open source R. It will take a little longer to run open source R on Spotfire because most likely you are not near an R engine data warehouse that can run your code. It's probably going to be sent to one in Colorado. I believe that's where TIBCO uses their R from. So it takes a few seconds for that to load back and forth between your state and Colorado. We don't need any packages here, but we will be loading them up here. So library forecasts will have some warnings, so that's why I suppress the warnings in this stage. They're pretty harmless. They're just namespace loading warnings that may collide with other packages. And for now, we're going to hard code these three really important features of the time series forecast. First of all, the confidence, we're just going to keep it at 0.75. H is the number of time periods we're going to forecast into the future. Right now we have it as 12, so we're going to forecast a whole year. I also like to call this NTPF. We'll see that later, number of time periods to forecast. but R uses H in its documentation. And the frequency, since we're doing monthly, we should probably change this to 12 because there's 12 months in a year, and ARIMA and Holt Winters like to take into account seasonality in their forecasts. So we need to know the frequency with regards to the year of our data. And then feel free to read through the rest of this. It's just fitting models and outputting them cleanly into an output data frame. So as far as input parameters go, at the moment, all we have is this CSV string that we're getting from our document property. So we're going to go ahead and add the input CSV. It's only going to be string. There's no numbers allowed. I'm going to have it be type value and make it required. And once again, that is going to be using the read.csv script or function in R to read that CSV. And then our one output parameter is going to be a data table, and we're going to call it output. And it's going to be a type table. You can put a better name for that in the description, display name if you want. We can call it forecast output, whatever. So allow caching, sure. Hasn't really hurt me too much with the forecast, but let's run this. Check this box. It's usually pretty good when it comes to forecasting with dynamic data. You want your R script to trigger automatically when your inputs change. That is a good property to have. And so now we got to link our inputs and outputs to actual Spotfire data. So if you recall, the CSV input parameter is going to be linked to a document property called forecast input, which contains the CSV of our cross table input. Output is going to be a data table, and we're going to create a new data table. We don't want to replace this one. It's going to be called forecast output, and whatever you want, or yeah, call it whatever you want. Okay. And I don't know if you saw on the bottom left here, but that just ran without any error. And now we can see we have forecast output. And this is what it looks like. So we have a date column. We're going to get to why that looks so funky in a second. We have a value column, which represents the historical data. If you remember, we got 5.08 in the first, corresponding to February 2012. We have the fitted Holt Winters forecast right here. So fitted means we're going to apply the model to time periods in which we already know the exact. But as you can see here, when we start extrapolating to the future, these are blank and we get onto the actual forecasts. So we have the mean forecast in the middle here, and then we have its two confidence intervals, upper and lower bounds, which this one will always be higher and these will always be lower than the mean forecast. And so these dates right here, these are actually integers. For some reason, Spotfire does not like reading in dates from R the way you want it to. So it's always a safe bet to just assume that your dates are going to be funky, whether they're going to be strings or ints. If they're ints like this is the number of days, I believe, since January 1st, 1970. A very important holiday for computer science and epochs. So we're going to have to insert a calculated column to make that date correct. And sorry, this is just the one wonky part of my solution here that we always have to remember is to insert this calculated column to get an actual date. And luckily I have that saved right here. I'm going to just pause for a second here so that you can take note of this expression. We're basically going to add a day to each date, which are just integers, starting from the date 1970-01-01 to get the current date that this represents. I'm going to call this month. If you just make sure that looks right. Yep, starting February 1st, 2012. Awesome. Going to 2019 because that's 12 months ahead from when we last pulled the data. So press OK, and we are good. All right, now on to the fun stuff. We get to visualize our Holt Winters forecast, and I'll show you the basic configuration I like to use when making a nice user interface to interact with our forecast. First, let me show you how to visualize these columns in a separate line chart. So let's move that right here. And we're going to now be using the forecast output table as our data table. using the month column we just calculated, and the value lowercase v is what we are trying to visualize. And if you recall, we're going to do an average. Doesn't really change anything. So yeah, that's just the exact same history that we've seen before. And now we can add the Holt Winters fitted line. The Holt Winters mean forecast is its own line. And the confidence intervals. Real nice. So yeah, and my standard procedure when trying to color these would be to make the value black, Holt Winters blue because I like blue, both mean and forecast, and then the confidence intervals will be more light blue so that they stand out more as confidence intervals. And there you have it. So now, as far as the user interface goes, if you've been following along with the ARIMA version of the script with the open source R, you may realize that having multiple forecasts visualized on the same line chart can be great and useful, but also messy if you have overlapping confidence intervals here, for instance, just flying around among different models. So I will first configure up here a simple multiple select list that will let the user choose which elements of the visualization he would like to see or she. So we're going to go to list box multiple select, and we do a new document property, display forecast elements, or whatever you want to call it. It's going to be a string. And when in doubt, fixed values are usually the way to go when creating more specialized UI like this one with nice names. So what are our elements? First we have history. The value for that is just going to be average value, if you recall from our data table. We can cheat a little bit and move this over. Read them out here. So next we have the Holt Winters forecast. And that's going to be average HW mean forecast. This is the most important part of arguably of this visualization. So to indicate sub elements, I'll just put 4 spaces and do fitted and confidence. And so if you're following along with the ARIMA, you can also put another ARIMA forecast here with fitted and confidence to follow the same pattern. So filling in these, and then so the confidence interval is going to have 2 because it's kind of pointless in my opinion to show them both separately without one or the other. So we're going to do a comma and just add them both. Right, that should work. And so what this string list data type will do is we can select multiple of these and it will append them to each other separated with commas. So that's why this comma thing will work here. And we'll see that in a sec. By selecting control, we can select all of these and edit our custom expression for the y-axis here to be the document property we just set up, which is called display. Where'd it go? There we go. Insert that right there. And so it's going to map it. Actually, the way we wrote it, we don't need to do that. So we're just going to get rid of all of this except for the display forecast elements part of it. Don't give it a display name because that might give you an error. Yeah, so it recolored it for us. That's okay. We'll just recolor it back. And that's how you do it. So now we can play around with this and just get rid of the confidence lines, for instance. Only show the forecast. Great. So lastly, most importantly now, we actually need to let the user be able to change what these confidence intervals are with regards to a percent. Right now it's stuck at 75% because that's how we have it hard coded. Also, we hard-coded the number of days to predict into the future, which is just 12, or months, sorry. So we are going to have to solve this problems using, drum roll please, document properties. So insert another input. This one's going to be an input field, I believe. Is that the one we need? Yeah, input field, because we're going to be typing in the number. And so this one for the confidence, just call it conf. We want it to be a real number since it's confidence is usually a number between 0 and 1 with decimal places. And for numbers, we need to specify a value. So we put 0.90. And that's going to be our confidence for text box. Do the same thing for H, or the number of time periods to forecast. No, not label. We're going to do another input field. New document property. I like to call this NTPF. Number of time periods to forecast. This will be an integer because we're not really going to ever forecast like 12.5 months. And value, default 12. Why not? Okay. So now these are free to be edited, but all they're going to do right now is just change the document properties. They're going to do nothing to this visualization. So we got to edit our data function. So we're going to go edit the script because we need to add 2 new input parameters. First, conf is going to be a value, type real. Oh, why not just all of the numeric? Why not? And it's a required parameter. We're also going to add NTPF, or actually in the R script I called it H. Sorry for the confusion. And this is always going to be an integer and required. So now we can get rid of this hard-coded mess. These are already defined by the inputs. Frequency, we're going to get that back in a second. We're just going to keep that at 12. Save it. Could not calculate inputs to forecast because we didn't actually link the document properties just yet. So that's a good error. So we can go to edit parameters, go to conf, and link it to that document property. And it already did it for us. Go to H, link it to that document property. NTPF is H. Output still output. Wonderful. Let's press OK. Background test. It's running, and it ran. Yay! So we can put the fitted. We can decrease the width of our confidence interval. Put 0.5. Nice. And we can do 24 months ahead. Great.